We often talk about global crises, in these abstract terms.
Right.
AI, economic collapse, things that might happen in 10 or 20 years.
Right. Future problems.
Exactly. But there's one challenge that is so immediate, so physical, and it's defining the survival of millions right now.
Water scarcity.
Water scarcity.
Yeah.
It is the defining challenge of our time. And usually, when we talk about solving it, the conversation goes straight to behaviors.
Sure. Turn off the tap, take shorter showers, all of that.
Yeah, conservation. And look, that's important. I'm not dismissing it. But looking at the research you've brought today, it seems like conservation is just a stopgap. The real solution. It isn't just about using less.
No.
It's about advanced engineering. It's about how we filter and process and, literally understand water at a microscopic level.
That's the core of it. Scarcity isn't just a lack of something. It's a lack of the right technology to access it. It's a physics problem. And to solve a problem that big, you need people who really get the fundamental forces of nature.
Which brings us to the subject of today's deep dive. Professor Nidal Hilal. Now, looking at his bio, calling him an expert feels... it feels like a massive understatement.
It really is. It's like calling Einstein just good at math. Professor Hilal isn't just a researcher. He is, and I don't use this word lightly, a titan in this field.
A titan.
Yeah, his career basically bridges the gap between fundamental physics, thermodynamics, molecular forces, and the industrial application of getting clean water out of a tap in a place that has none.
So to give everyone a sense of the scale we're talking about, let's just start with the wow metrics.
Yeah.
Because the numbers here are frankly staggering.
They are.
Okay, let's unpack this. Over 600 peer-reviewed articles. But it's not just the papers. He has written more than 90 book chapters and published 12 authoritative handbooks.
And let's be clear about what those handbooks are. These are published by the heavy hitters.
Like who?
We're talking Elsevier, CRC Press, Taylor and Francis. In the academic world, those names are the gold standard. If you are an engineering student anywhere on the planet, chances are you're reading his work.
And people are definitely reading it. The citation count is over 50,000.
Which is just incredible. That puts him in the top fraction of a percent of millions of scientists. Clarivate, the company that tracks this, lists him as a highly cited researcher. That's the top 0.10% globally.
Yeah.
And in the journal Desalination, which is the premier journal for this whole industry, he is the most cited lifetime author.
Most cited ever.
Ever. It's a legacy.
But let's get even more specific on the rankings, because this is where it gets really interesting.
Yeah.
He isn't just a general water guy.
No. He dominates specific technologies. He ranks #1 worldwide in membrane distillation, nanofiltration, and ultrafiltration.
#1.
He's #2 worldwide in reverse osmosis technology. And in the broader field of desalination, he's currently sitting at #7 globally.
So how does someone even get there? You don't just wake up one day and become the world's leading authority on membrane tech. Where does this story start?
It actually starts from very humble beginnings. He was born into a modest family of 8. His parents' formal education didn't go beyond high school, but the sources really emphasized that they valued learning deeply.
And I'm guessing that growing up in a region where water is a precious resource must have shaped his thinking.
Absolutely. The sources say he saw resource scarcity firsthand, and that created this driving motivation. He had a vision: go abroad, get the best scientific knowledge possible, and then bring it back, reinvest it in the Arab world to help build regional independence.
So a brain gain, not a brain drain.
Exactly. He left with the intention of returning. He heads to the UK in 1983. But here's a really crucial part of his story. He didn't just go straight to the library. He started in industry.
Doing what?
He was a process supervisor in the petroleum sector.
Petroleum? That seems like the opposite of clean water.
It does on the surface, but for an engineer, it's the perfect training ground. You're dealing with process engineering on a massive scale. High pressures, complex fluids.
So he learned how to make things work in the real world, not just in a lab.
He learned that things have to be scalable. That industrial mindset is something he carried right through his academic career. So after that, he goes to Swansea University for a master's in advanced chemical engineering in '85.
And then the PhD.
And the PhD in 1988. And this is where we have to geek out for a second, because his PhD topic is, well, it's fascinatingly not about water.
Okay, wait on me.
His PhD was supervised by Professor Donald J. Gunn, and it was on heat transfer and thermodynamics in fluidized bed reactors.
I hear heat and reactors. I am not hearing water.
And that is the secret sauce. He didn't start with the application, he started with the deep physics. A fluidized bed is where you push gas or liquid through solid particles so they act like a fluid. It's incredibly complex.
So why does that matter for a water filter?
Because it gave him this deep foundation in what we call transport phenomena and surface interactions. He understood the thermodynamics, the fundamental rules of how energy and mass move between surfaces.
So later, when he looks at a membrane, he's not just seeing a filter, he's seeing.
He's seeing the energy exchange, the physics of how a single water molecule interacts with a membrane surface. He mastered the grammar of physics before he tried to write the poetry of water treatment.
That's a great way to put it. And I see he also got a postgraduate certificate in academic practice.
Yes, which just shows his parallel commitment to teaching. He wasn't just a researcher, he was an educator.
So let's talk about that UK career, because he spent decades there building a really serious reputation.
He did. He started as a postdoc at Swansea with Professor W. Richard Bowen, but his time at the University of Nottingham from 2001 to 2010, that was a period of really rapid ascent.
From lecturer to
Senior lecturer, then reader, then a personal chair, which is a full professor of chemical process engineering.
And he wasn't just teaching, he was an institution builder.
Exactly. He founded and directed the Center for Clean Water Technologies at Nottingham. He was deputy head of school. He was learning how you organize science to get results.
And the institutions took notice.
Oh, absolutely. Fellow of the Institution of Chemical Engineers since 2002, the Learned Society of Wales since 2013, and just recently, the Royal Society of Chemistry in 2023.
That's the trifecta of British scientific recognition. But Swansea eventually called him back.
They did. In 2010, he returned to Swansea as the chair in water process engineering, and he did what he does best. He built another institution. He founded Seawater,
Which is?
the Center for Water Advanced Technologies and Environmental Research. And under his leadership, this center became one of the world's leading hubs for membrane and desalination research. It really transformed the UK's water tech landscape.
I want to pause on the science again. We said he's number one in things like nanofiltration. But what did he actually discover? What were the firsts?
This is where that physics background just shines. He's a pioneer in something called atomic force microscopy, or AFM.
Okay, explain AFM like I'm 5.
Imagine you're trying to feel the texture of a rug in total darkness. You'd use a very fine needle, right? Now imagine that needle is the size of just a few atoms. That's AFM. It lets you feel and map a surface at the nanoscale.
And he applied this to water filters.
He developed the smallest AFM colloid probe ever reported. This gave him incredible precision. With it, he was the first person to actually visualize and quantify the pores in nanofiltration membranes.
Wait, so before him, we couldn't actually see the pores.
There were huge debates about it. He settled them by providing the images. He also did the first direct measurements of the adhesion forces between, say, a single bacteria cell and a membrane surface.
Adhesion forces. You mean how sticky they are?
Precisely. The enemy of desalination is biofouling gunk sticking to the filter and clogging it. By measuring exactly how much force it takes for a cell to stick, he gave engineers the data they needed to design self-cleaning membranes.
That is the definition of usable tech. Which brings me to another innovation of his that I find amazing. Recycling plastic waste.
Yes, this is his philosophy in action, solving multiple problems at once. He focused on developing ways to recycle plastic waste into high-performance filtration membranes.
So you take plastic trash, a massive global problem, and you turn it into a tool to solve water scarcity, another massive global problem.
It is the circular economy perfectly executed, and he proved it works at scale. He oversaw the manufacturing of the first industrial-scale reverse osmosis module made in the UAE, taking it from the lab to the factory floor.
And speaking of the UAE, let's talk about that strategic shift. He had that goal as a young man to bring knowledge back to the region.
And he did, in a big way. From 2012 to 2014, he was appointed provost and chief academic officer of the Masdar Institute in Abu Dhabi.
Provost is the huge job. That's not running a lab, that's running the academic side of a university.
Exactly. He was overseeing all academic and administrative operations, and he was on joint executive and steering committees with MIT, the Massachusetts Institute of Technology.
So he's working with MIT to build a world-class research ecosystem in Abu Dhabi.
He was one of the architects. He helped establish advanced research centers, world-class labs. His leadership was direct. He was shaping one of the region's most advanced innovation hubs.
And he's still there now at NYU Abu Dhabi.
Yes, since 2018, he's the founding director of the Water Research Center there. And just recently, he was named to New York University's Faculty Honors List.
What does that signify?
It recognizes faculty who've achieved major international distinction. Prizes, patents, global leadership. It's a validation that his work is having a massive global impact.
We have to run through the trophy cabinet because it is extensive.
It is. Back in 2005, he received the Kuwait Prize in Applied Sciences,
Which my notes say is called the Nobel Prize of the Arab world.
That's how it's regarded. It's one of the highest honors in the region. That same year, the University of Wales awarded him a Doctor of Science, a DSc.
Which is different from a PhD, right?
Very different. A PhD is your ticket to the game. A DSc is a senior doctorate. It's one of the highest academic honors there is, recognizing a huge sustained contribution to your field.
And more recently.
In 2020, the Menelaus Medal. That's the highest honor in engineering in Wales. And just this year, 2024, the Global Prize for Innovation in Desalination for Breakthrough Energy-Efficient Tech.
He's also on the advisory board for the X Prize for Water Scarcity.
Which is huge. It means he's now shaping the criteria for the next generation of solutions. He's setting the bar for the future.
Beyond the prizes and the papers, there's a human legacy here, too.
A huge one, mentorship. He has supervised 48 PhD students.
48. That is a small army of researchers.
It is. And a PhD is 3, 4, sometimes 5 years of intense supervision. That is a massive investment of time. But those students are now in senior positions all over the world. In academia, in industry, he's multiplied his impact.
It's clear his philosophy is about more than just science for science's sake.
Absolutely. The sources really paint a picture of someone who believes that curiosity has to be matched with responsibility. He acquired the knowledge and then he reinvested it. He built the bridges.
From a boy in a modest family who saw scarcity firsthand to the man helping solve water security for the world. It's quite an arc.
It is the complete realization of that early vision.
So when we step back and look at all this, what does it mean for us? You look at Professor Hilal's work recycling plastic into membranes, making fresh water from the sea. It just shifts your perspective.
It really does.
We tend to think of water scarcity as a problem of lack. We just don't have enough. But his work suggests it's actually a problem of inefficiency. The water is there, the materials are there. We just need the right engineering.
And that way of thinking applies to more than just water.
Exactly. So here's the thought I want to leave everyone with. If we can turn plastic waste into water filters, what other so-called waste problems are actually resource solutions, just waiting for the right engineer to come along?
A powerful question.
That's it for this deep dive into the life and work of Professor Nidal Hilal. Thanks for listening.
Thank you.